Hello, my dear student. I'm Saktwala from Educare TZ. I'll be with you in physics for Form 5. So, my dear student, welcome again for our discussion for our topic of rotation of a rigged body, for our subtopic of torque of a rotating rigged body. So, today we are going to proceed with another part here. So before we proceed with our discussion, now we are supposed to think where we ended on the last session. On the last session, my dear student, we tried to see example related with the torque. How can we get the torque when either a rigged body trying to rotate? It means trying to rotate on a wheel, as we tried to see. We try to see that examples that aims us to find the angular acceleration and also the velocity or the linear velocity. And we say that this if we have the two masses that are placed at a certain distance, they are trying to be rotated. Now the acceleration must be obtained by taking the difference of their masses. Then we times it by the acceleration due to gravity. We divide it by the summation of their masses. Then we add it by the moment of inertia divided by r square. This is what we tried to demonstrate, and after there we obtained the value of the acceleration and substituted and recorded. We tried to recall the equation, the third Newton law equation, is so as to find the velocity. But now let us go and see the work done or by the torque. How can we get the work done by the torque? That is what we are going to try to demonstrate for our today discussions. So first of all, we have the work done by the torque. We could proceed here without understanding the meaning of the work done and also the torque. When we talk about the work done, this is the product of the force and also the distance. This is the meaning of the work done. But the torque, we say that also this is the product of the force times the perpendicular distance from the point where the force is applied. So here, imagine applying a tangential force to a wheel with the radius r. Now this force causes the wheel to rotate about the center or through an angle. That we have the wheel, and that wheel trying to rotate. During the rotation of the wheel, we must apply the tangential force, kwamba ile tangential force ambayo tumeiapply pale ili kuweza kusababisha ile wheel iweze kufanyaje, iweze kuzunguka. Sasa tukisha apply ile tangential force itasababisha ili wheel iweze wheel kama matairi haya ya gari yaweze kuzunguka. Kwa hiyo inapokuwa ina rotate hivyo about the center through an angle here, itaweza kuproduce an angle theta, as we try to demonstrate here. So as we are going to see our figure number 22 here. And our figure number 22, they are going to see how the tangential force, after the tangential force being applied, may cause the wheel to rotate at a certain angle theta. That is what we are going to see for our discussion here. So this is our figure here. This representing the wheel, and this wheel with a tangentially applied force is rotating about an axis, trying to rotate about an axis with the constant angular velocity, as we try to see. This is the force that is applied. When the force is applied, cause the wheel to rotate on it is an axis at a constant angular velocity, as we see here. So the force, when the force is applied at the point A, now may produce the distance, means the radius from the center, and also may form the angle theta between the point A and also at the point B. And at the point B here, we have the tangential force which is applied. This is F. But all of these tangential force are the same. Because tangential force that is applied at point B must be equals to the tangential force that is applied at the point A, my dear students. Now here is how the tangential force cause this wheel to rotate on it is an axis. Now we could conclude by saying that the speed of each mass is 0.16. This is an error, my dear student, that we tried to get when we demonstrated. Hii ilitakiwa kwenye slide iliyopita. Tumejaribu kupata ni kama an error. So here, if we live with this slide, let us jump for this slide here. That the work done by the force F in turning the wheel through the angle theta, which is suspended by the arc AB, is given by W here. So we can say that the work done that is applied, the work done by the force F in turning the wheel through the angle theta suspended to the arc here is given by this one. How can we get the work done? Sasa tukirudi kwenye figure yetu hapa, tunataka work done aliyebini applied for the force AB. How can we get the work done at that is used to turn the wheel rotating on it is an axis? Tutamwambia kwamba tutampata ule work done kwa kumchukua huyu force aliyebini applied neutral times by the distance. That is what we try to see. We can say work done from our figure must be equals to the force. Then we multiply by the arc length or the arc distance exactly between the point A and also B. Since the arc distance AB is equal to r theta, as we know that the arc distance that exactly into our wheel is equal to r theta. Now we can express the work done as this one. Kwa kama yule work done tumeshampata, yule work done tumesema ni sawa na force times the arc distance. Therefore tutamwambia kwamba kwa sababu pale kwenye arc length tulisoma kabisa kwamba yule length anakuwa ni sawa na r theta. Kwa arc length ambayo kama exact pale kutoka kwenye point A mpaka kwenye point B katakuwa direct proportion to the theta. But if we want to reduce the direct proportion, tutaweka r. Kwa tutamwambia kumbe arc length ambayo ni sawa na distance along the point AB must be equals to r theta. This could be our formula here, as we see. Instead of writing the arc distance AB, we could substitute equals to r theta. Now we say that work done must be equal to force times the r theta. But we can we are supposed to take it to combine, to introduce a bracket between the value of FR, and we know that this FR represents the torque. Kwa sababu tunajua torque ni sawa na nini? Torque ni sawa na force times the perpendicular distance. Kwa huyu force R atakuwa ni sawa na torque, na ndio maana tumeona instead of writing FR we have tried to write the torque, and we labeled that this might be our equation number 74, that explain how to obtain the work done in respect with the torque. Kwa tunamwambia sasa, therefore for the torque work done must be equal to the torque times the theta. But theta here represent the angular represent the angular displacement. Huyu theta ata represent the angular displacement. So hence this torque we know is equal to FR represent the torque. As we know that why we tried to put this torque here. We tried to put this torque by omitting FR because the torque is equal to FR. Kwa ndio maana tumeweza kusubstitute, badala ya kuweka ile torque, badala ya kuweka ile FR tumeweka ni sawa na torque. So the formula that we will use on our rotation, on our topic of rotation of a rigged body for finding the work done might be equals to torque times the angular displacement, where this symbol represents a torque of the applied to the wheel, my lovely student, as we try to demonstrate here.